Okay, so for our last two examples of finding annihilators, we're going to take a look at two more complicated examples. Our first one is to take a look at an x times the e to the 2x times the cosine of 3x. And you kind of just want to work yourself backwards with these problems. And the idea is you want to first focus on the exponential. And we know that that's going to be d minus 2 that annihilates the e to the 2x. But then, because we have a complex number, we know we have to square and add. And then we know it's going to be plus 9 to eliminate or annihilate that cosine of 3x. So these two parts here, these two components, will eliminate the e to the 2x and the cosine of 3x. But now we've got that x in front. And remember, coefficients of x means there's repeats going on. So that means that we have a repetition of our roots, and so therefore it's going to be d minus 2 squared that we pick for our annihilator. And again, we could actually check this by going in and finding this derivative, but again, if you think about this derivative, it's horrible because this would be a fourth derivative applied on a triple product rule. So this is probably like a good hour-long or 2-hour-long calculation to verify. So therefore, we will just take it on faith that this function right here does, in fact, annihilate this function here. So again, that's our operator to annihilate that function. For the next and last example of finding annihilators, let's take a look at f of x is equal to x cubed e to the negative 2x times the cosine of 5x. And once again, you really want to think about these problems in reverse as you solve them. The easiest part to tackle is the exponential part. So the e to the negative 2x, that would be a d plus 2. That would be the annihilator for that. But now, because we have a cosine, we know we have to square this and add on the square of the coefficient, which is going to be 5 squared, which is 25. So this part alone annihilates these two parts. But now we have a repetition that's modeled by the x cubed. So if you think about it, that means this was repeated 4 times. So therefore, we have to go in and put this whole thing to the 4th power to capture that derivative. And once again, you would not want to actually check this by hand because it would be very, very challenging. Now, you could use a computer program like Wolfram Alpha, or use something like Maple or Mathematica, and they'd actually be very quick at this. But by hand, as a person, this would be a very, very tough, long calculation. It's a triple product rule done 6 times, and that would just be a horrible, horrible calculation. So we're going to just take this here as our annihilator for that function there.